Every morning, someone sprays them dead. Herbicide, Roundup, whatever is cheapest and kills fastest. The ones pushing through the cracked concrete, the ones strangling the flower beds, the ones your neighbor calls an eyesore and your municipality classifies as a nuisance species subject to abatement fines. Those plants, the ones you have been poisoning for decades. What if I told you that before 1910, before a single pharmaceutical patent existed for a synthetic compound, those exact plants were the backbone of every serious apothecary between London and Lahore? What if I told you that the decision to call them weeds was not botanical, it was financial? 7 plants. That is what this is about. 7 medicinal species that were systematically reclassified, restricted, and in some cases outright banned from internal use by regulatory bodies that were funded, lobbied, and in several cases directly staffed by the nascent pharmaceutical industry of the early 20th century. 7 plants your ancestors would have recognized on sight and used without hesitation. 7 plants that the American Medical Association's 1910 Flexner Report effectively erased from every accredited medical school curriculum in North America within a single decade. You need to understand the mechanism, because it was not crude, it was elegant. Abraham Flexner was not a doctor, he was an educator. He was hired by the Carnegie Foundation, which was itself funded by John D. Rockefeller's Standard Oil wealth, to audit the state of American medical education. His report condemned the empirical, plant-based healing traditions practiced at more than half of American medical schools as unscientific and dangerous. His solution was a standardized curriculum built entirely around laboratory-derived, patentable pharmaceutical interventions. Within 10 years, over half of American medical schools had closed or been absorbed. The ones that survived taught what the new curriculum demanded: prescription drugs, surgical intervention, and zero-botanical pharmacology. A plant you can grow in your own yard cannot be patented. It cannot generate shareholder value. It had to go. But here is what they could not erase. The knowledge survived in pre-1910 pharmacopoeias, in Vedic texts predating the Roman Empire, in the field notes of Civil War surgeons who packed wounds with preparations that the modern hospital has never replaced with anything more effective, in footnotes that nobody reads because nobody teaches anyone to look for them anymore. I have been looking for a long time. 7 plants. Stay with me through all 7. Because plant 4 is the one that stops me cold every time I return to the Civil War field surgery records. It is a coagulant so effective that Confederate field surgeons kept dedicated pouches of it for hemorrhage management in the absence of any other intervention. The Union Army knew it. Both sides used it. And it grows in your yard right now. You have probably mowed it down this week. And plant 7, the deep earth cellular purifier. I did not understand what I was reading the first time I encountered it in the Sushruta Samhita, the Vedic surgical text compiled around 600 BCE. The description made no sense in modern terms until I cross-referenced it with a 1951 clinical study conducted at the University of Vienna, a study that was never replicated because the funding was withdrawn the same year the pharmaceutical company sponsoring it filed a patent for a synthetic compound with a structurally adjacent mechanism of action. What Plant 7 does at the cellular level is not herbal medicine in the way that phrase has been conditioned to sound dismissible. What it does is documented, specific, and buried. We start at the beginning, with the one they tried to ban from internal use entirely. The one that has a 2,000-year paper trail of fusing fractured bone that the modern medical establishment has tried to classify as too dangerous to consume. And with the second plant, the one the medieval Benedictine monks used for something that would today require a prescription and a psychiatric evaluation. The bone fuser. That is what we are talking about first. The plant the Old English herbalists called knitbone, the one whose name in classical Greek, symphytum, translates directly to that which causes things to grow together. The pre-pharmaceutical world was not speaking poetically. They were describing a biochemical mechanism that modern science has since confirmed in peer-reviewed literature and then systematically refused to act on. Pedanius Dioscorides documented this plant in De Materia Medica around 65 CE. He described the root preparation in specific terms: boiled in wine, applied as a poultice to fractures and joint injuries, taken internally as a decoction for internal bleeding and ruptured tissue, not as a curiosity, as a first-line intervention. The Roman legions carried it, not because Roman commanders were herbalists with an interest in folk tradition, because it worked in field conditions where nothing else was available, and the alternative was amputation or death. The active compound responsible for this is allantoin. Look that name up. Allantoin is a cell proliferation accelerant. It stimulates the rapid division and migration of fibroblast cells, which are the cells responsible for connective tissue repair and bone matrix regeneration. Modern cosmetic companies put pharmaceutical-grade allantoin in wound creams and anti-aging serums. They sell it, they patent their delivery systems around it. They do not tell you that the highest natural concentration of allantoin on the planet exists in the root of a plant that grows as a weed in temperate zones across Europe, Asia, and the eastern half of North America. You do not need the cream. You never needed the cream. Look at the stem if you are standing near one. It is rough, hollow feeling when pressed, covered in stiff hairs that catch on clothing. The leaves are large and lance-shaped, running down the stem in a distinctive winged pattern that is unique enough to identify the plant at 10 feet. The flowers are tubular, bell-shaped. They hang in clusters and shift color across the season from cream to purple to pink. That color shift is significant. I will come back to that. It tells you something about the alkaloid load that most modern foraging guides get completely wrong. The root itself is where the concentration lives. Black or dark brown on the outside, pure white when cut, mucilaginous. It smells faintly of beets and something older, deeper, harder to name. When you cut it, it bleeds a thick white sap that stains fingers brown and does not wash out easily. That sap is the mechanism. That sap is what 2,000 years of documented human use was pointing at. Here is what the modern regulatory story does not tell you cleanly. In 1978, the German Federal Health Agency identified pyrrolizidine alkaloids in the plant's root and leaves. Pyrrolizidine alkaloids are hepatotoxic in sufficient doses. They accumulate in liver tissue. In high-dose animal studies using concentrated alkaloid extracts far beyond any traditional preparation, they produced liver damage. The regulatory conclusion drawn from those studies was that internal use of the whole plant root was unacceptably dangerous. The European Medicines Agency followed. The FDA issued guidance restricting products containing the plant's internal use preparations in the United States. The traditional preparation had never used concentrated alkaloid extracts. It had used root decoctions, poultices, and infusions prepared in ways that dramatically reduced pyrrolizidine alkaloid content through the simple chemistry of water extraction and heat. The 1978 studies did not test traditional preparations. They tested isolated alkaloid concentrates administered in doses no traditional practitioner had ever recommended. The distinction was not made clearly in public-facing guidance. The plant was erased from the internal medicine shelf. The allantoin went into the patented cream. A 2004 clinical trial published in Phytomedicine using a low-alkaloid topical extract of the root demonstrated statistically significant acceleration of fracture healing versus placebo. The conclusion of that study acknowledged the 2,000-year traditional record and recommended further investigation. That investigation has not been substantially funded. The cream sells. The investigation does not generate revenue. That is not an accident. That is a pattern, and the pattern repeats with every single plant on this list. The monk's plant is next, and the reason it connects to the bone fuser is not obvious until you understand what it was actually being used for inside those medieval monastery walls, because it was not what the modern supplement industry will tell you it was. The Benedictine monasteries of the 9th and 10th centuries were the primary institutional repositories of medical knowledge in Western Europe. The monks were the physicians. The monastery gardens were the pharmacies. And in those gardens, one plant above all others was cultivated specifically for conditions that the Church officially classified as spiritual afflictions, but which the monastery physicians treated as neurological emergencies. Severe nerve pain, what we would now recognize as major depressive disorder. What the records describe as melancholia profunda, a state of such complete psychological collapse that the afflicted could not eat, speak, or function for weeks or months at a time. This was not treated with prayer alone. It was treated with a preparation from a plant with small golden flowers and dark oil glands visible along the leaf margins. Look at the leaf against light. Hold it up. Those tiny translucent dots you can see through the leaf surface are the oil glands. They are the identification mark. They are what separates the genuine medicinal species from the dozens of similar yellow-flowered plants sharing its habitat across European meadows and roadsides. The monks called it fuga demonium, the chaser of demons. That name was theological. The mechanism was pharmacological. The plant's red pigmented compound, a naphtodianthrone called hypericin, was producing measurable effects on serotonin and norepinephrine reuptake that no one had the language to describe in biochemical terms until the 20th century. But the monks knew what they were observing. They kept meticulous records. The Hildegard von Bingen writings from the 12th century describe preparation protocols for this plant, so specific in their timing, their solvent, and their dosage that modern pharmacological researchers who have read them describe them as inadvertently optimizing for hypericin and hyperforin extraction. Hildegard did not know what hypericin was. She knew what the plant did. She knew how to make it work. And that knowledge survived for 900 years in monastery archives until the pharmaceutical industry found a more profitable way to address the same conditions. In 1987, a large-scale meta-analysis published in the British Medical Journal synthesized data from 23 randomized trials involving over 1,700 patients. The conclusion was unambiguous. For mild to moderate depression, this plant extract outperformed placebo and demonstrated comparable efficacy to standard tricyclic antidepressants, with a significantly reduced side effect profile. The study's findings were widely cited in European medical literature. Germany's Commission E approved the plant extract as a first-line treatment for mild depression in 1984. 3 years before the meta-analysis was published. The American response was different. The FDA declined to classify it as a pharmaceutical. It was regulated as a supplement, which meant no specific therapeutic claims could be made on labeling, no insurance reimbursement, no physician prescription track, and no institutional credibility in clinical settings. A supplement sits on a shelf. A prescription sits in a physician's hand and generates a billing code. The economics of those two positions are not comparable. And here is the variable most people who take this plant as a supplement never hear about. This is the thing I wish someone had told me before I wasted 8 months expecting results I was not going to get from the preparation I was using. I spent the better part of a year convinced this plant was overhyped. I was taking a standardized capsule extract. I was getting nothing. I went back to the pre-pharmaceutical literature because that is what I always do when the modern version of something is not delivering what the historical record says it should deliver. What I found was a preparation detail buried in a 1923 German pharmacognosy text that I tracked through 3 university library interloan requests before I got my hands on a photocopy. The detail was about light exposure during extraction. Hypericin, the active compound responsible for the antidepressant mechanism, is photosensitive in ways that standard commercial extraction processes destroy. The traditional preparation involved controlled sun steeping in specific temperature conditions that activated the compound rather than degrading it. Every mass-produced capsule on the supplement shelf is prepared in temperature-controlled light exclusion facilities designed for shelf life stability, not for hypericin activation. The ancient preparation and the modern supplement are not the same product. They share a name. They do not share a mechanism. That is not on the label. That will never be on the label because fixing the preparation problem would require abandoning the industrial extraction process. And the industrial extraction process is what makes the supplement profitable at scale. There is one more thing about this plant that connects it backward to the bone fuser and forward to everything that follows. The look-alike situation here is serious, and I mean that with specific clinical weight. St. John's wort grows in disturbed soil, roadsides, meadows, and open forest edges across the northern hemisphere. It shares that habitat with several species in the same genus, some of which have no medicinal value, and at least one of which is actively toxic in the dose ranges where the genuine species is therapeutic. The identification test that matters is the oil gland test. Look at the leaf. Hold it to light right now if you have a plant near you. Translucent dots scattered across the leaf surface. That is the genuine species. No dots means you have the wrong plant entirely. The stem squareness is a secondary confirmation. 4-sided stem. Press it between your fingers and feel the angles. Round stem is wrong. 4-sided stem is right. Both identifiers together, not one. Both. There is also a pharmaceutical interaction that the supplement shelf will not tell you clearly enough. This plant is a potent inducer of cytochrome P450 enzymes in the liver. That means it accelerates the metabolic breakdown of a significant list of pharmaceutical drugs, including certain antiretrovirals, organ transplant rejection medications, oral contraceptives, and blood thinners. The interaction is not theoretical. It has been documented in clinical case studies with serious adverse outcomes. If you are on any prescription medication and you are considering this plant, that interaction question is not optional. It is the first question. The monks who developed this preparation were not on antiretrovirals. The interaction issue is a product of the pharmaceutical age, not the plant. The plant did not change. The world around it changed, and the result is a preparation that requires more precision than the supplement label suggests. What comes next on this list is the one that broke the bone fuser's historical record. And the break happened not in a laboratory or a regulatory hearing. It happened in a muddy field in 1863 at the Battle of Gettysburg. Field surgery in the American Civil War was not surgery in any modern sense of the word. It was triage performed under fire with no antibiotics, no sterile technique, and no reliable anesthesia beyond whiskey and speed. The surgeons who survived that environment longest were not the ones with the most medical school training. They were the ones who learned fastest from the soldiers who had been farming and foraging that land for generations. There was a plant those soldiers knew, both sides, Confederate and Union alike, a plant so common across the Eastern American landscape that it grew at the edge of every field, every trail, every creek bank where the fighting happened. A plant with feathery, finely divided leaves that look almost like green lace when you hold them up. And when a soldier was bleeding from a wound that no tourniquet was reaching effectively, the ones who knew what they were doing reached for that plant before they reached for anything else. The records exist. Regimental surgeon logs from the Army of the Potomac document the use of a poultice prepared from a common roadside herb for hemorrhage management in field conditions. The plant is not named generically in those logs. It is named specifically, and the name it is given is the same name that Achilles used for it according to Homer, the same name recorded in the Iliad when the hero used it to treat the wounded Telephus on the battlefield outside Troy. That detail stopped me the first time I read it. Homer, 800 BCE, American Civil War, 1863. The same plant, the same application. 2,600 years of documented battlefield use, and the modern hospital does not have it on a single formulary. The active mechanism is not mysterious. This plant contains achilletin and achillene, alkaloids with documented hemostatic properties that accelerate platelet aggregation at wound sites. It also contains azulene, a potent anti-inflammatory compound produced during steam distillation of the plant's volatile oils. The tannin content in the fresh leaf creates an astringent action on damaged tissue that mechanically supports clot formation while the alkaloids work at the biochemical level simultaneously. Two mechanisms, one plant. Growing at the edge of your driveway right now, the leaves are the identifier. Look at them closely if you have access to the plant, finely divided, feathery, almost ferny in appearance, deeply cut into dozens of tiny segments along each side of the central stem. That leaf structure is the primary identification marker. The stem is rigid, slightly angular, covered in fine white hairs. The flowers grow in flat-topped clusters at the top of the plant, white to pale pink. Each individual flower head tiny but packed densely enough that the overall cluster looks almost like a single large bloom from a distance. Smell the crushed leaf. It is sharp, medicinal, slightly bitter. That smell is the azulene precursor. That smell means you have the right plant. The look-alike danger here is real, and it is specific. Poison hemlock shares disturbed roadsides and open meadow edges with this plant across much of its North American and European range. Poison hemlock killed Socrates. It will kill you. The distinction is in the stem. Look at the stem directly. Poison hemlock has purple-red blotches or spots on a smooth, hollow, hairless green stem. This plant has a solid, hairy stem with no spots, no purple markings, no blotches. Look at the stem before you touch anything else. That is the only test that matters in the field. Smooth purple spotted stem means put it down and walk away. Hairy green solid stem means you are looking at the right plant. In 1974, a clinical pharmacology review published in the journal Planta Medica documented the hemostatic activity of achillene in controlled conditions and described the compound as warranting further investigation as a natural coagulant for topical wound applications. That further investigation was not substantially funded. The review cited a clear mechanism, a 2,600-year use record, and a safety profile that made it appropriate for controlled clinical study. The funding went elsewhere. The synthetic coagulants that did get funded and developed are now sold under brand names at significant cost per unit and require prescription or clinical administration. The plant that does a comparable job in emergency field conditions is classified as a common weed and mowed down by municipal maintenance crews on a schedule. That is Plant 4. And the connection between what it does on a battlefield and what the next plant on this list does inside the body is a connection the pre-pharmaceutical world understood completely, and the modern world has been trained not to make. Dandelion. You already know that name. You have spent money killing it. You have probably spent more money killing it than you have spent on any herbal supplement in the last 5 years. And I want to sit with that for a moment, because it is the cleanest summary of the entire erasure story that I can offer you. Taraxacum officinale, every part of it is pharmacologically active. The root, the leaf, the flower, the milky white sap that bleeds when you break the stem. Pre-pharmaceutical European medicine classified it as a primary hepatic tonic, a cholagogue, a diuretic, and a bitter digestive stimulant, which in practice meant it was used for liver congestion, bile duct sluggishness, kidney fluid regulation, and chronic digestive dysfunction. The British Pharmacopoeia carried it as an official medicinal preparation until 1953. 53 years after the Flexner Report began dismantling botanical medicine as a legitimate clinical category, the dandelion root was still in the official pharmacopoeia. It took until 1953 to finish removing it. The root is where the liver mechanism lives. Taraxacin and taraxacerin are the bitter sesquiterpene lactones that drive bile production and flow. Bile is not secondary chemistry. Bile is how your liver processes fat-soluble toxins, how it manages cholesterol metabolism, how it clears hormonal metabolites from the bloodstream. A liver with sluggish bile production is a liver that is not clearing what it is supposed to clear. The dandelion root is a direct stimulant to that clearance mechanism, not through general toxin binding or vague detox language, through a specific cholagogue action that increases bile volume and flow rate. The leaf is a different mechanism entirely. The dandelion leaf is one of the most potassium-dense plant foods available in temperate climates, which makes it unusual among diuretics, because most pharmaceutical diuretics deplete potassium as a side effect. The dandelion leaf drives increased urine output while simultaneously replenishing the potassium that the increased urine output would otherwise deplete. It is a self-correcting diuretic. The pharmaceutical industry has not produced a synthetic compound that replicates that self-correction. They produce the diuretic. They sell the potassium supplement separately. A 2011 pilot study published in the Journal of Alternative and Complementary Medicine documented significant increases in urinary frequency and volume in human subjects following dandelion leaf extract administration, confirming the traditional diuretic claim in controlled conditions. A 2016 study in evidence-based complementary and alternative medicine documented the liver protective effects of dandelion root extract in cases of diet-induced liver damage in animal models, with results that were described by the researchers as warranting urgent human clinical trials. Those clinical trials have not been conducted at scale. The weed killer is still cheaper than the clinical trial. Here is the confession I need to make about this plant specifically. I dismissed it for years. I am putting that on record. I spent a decade reading suppression histories of obscure Himalayan botanicals and Vedic root preparations, and writing off dandelion as too common, too familiar, too unsuppressed to be interesting. I thought the presence of dandelion on every lawn in North America was proof that nobody had ever found it threatening enough to erase. I was wrong about the logic. The presence of the plant was never the target. The knowledge of how to use it was the target. They did not need to eliminate the dandelion. They only needed to convince you it was a weed. That was enough. You did the rest yourself. Every bottle of Roundup you purchased was the erasure completing itself through your own hands. That is the mechanism. That is how efficient it was. The sixth plant on this list was used in ancient Egypt as a wound sealer and embalming preservative. It was described in the Ebers Papyrus around 1550 BCE as a treatment for skin infections, burns, and internal inflammation. It was carried by Alexander the Great's army specifically for wound management. The Arab physician Ibn Sina, whom Western medicine knows as Avicenna, dedicated significant attention to its preparation in his Canon of Medicine in the 11th century CE, recommending specific decoction methods for internal use in inflammatory conditions of the bowel and stomach. You know it as a common roadside plant with thick, ribbed oval leaves that hug the ground in a flat rosette. Look at the underside of one of those leaves if you have one near you. Run your finger along it. Feel the parallel veins running the length of the leaf. Count them. There are typically 5 to 7 prominent parallel veins running from stem to tip. That parallel venation on a broad oval leaf close to the ground is the identification key. The seed head is a dense cylindrical spike rising from the center of the rosette. The seeds are sticky. They cling to clothing and animal fur. That is how it spread across North America so completely after European contact. It is not native here. It arrived with the colonizers and spread along every trail and road they built. The indigenous nations who encountered it called it white man's foot because it grew exactly where white men walked. Plantago major, plantain, not the banana relative, the roadside leaf. The active compounds include aucubin, an iridoid glycoside with documented anti-inflammatory and antimicrobial properties, and plantagenin, which has been studied for bronchodilatory effects in respiratory inflammation. A 1990 study published in the journal Phytotherapy Research documented significant anti-inflammatory activity in aucubin extracts comparable in some measures to pharmaceutical anti-inflammatory compounds. A 2015 review in the Asian Pacific Journal of Tropical Biomedicine synthesized multiple studies confirming antimicrobial activity against a range of common bacterial pathogens, including Staphylococcus aureus strains that include antibiotic-resistant variants. The fresh leaf application for wound management is what the ancient record emphasizes most consistently. Crush the fresh leaf. Apply it directly to a cut, a sting, a burn, a splinter wound. The mechanism is not folklore. The aucubin is delivering anti-inflammatory action. The tannins are creating astringent tissue contraction. The mucilage is forming a physical barrier over the wound surface. 3 simultaneous mechanisms from one crushed weed you are currently stepping on without noticing. The internal preparation for bowel inflammation is a decoction of the dried leaf, not the fresh leaf. The drying process concentrates the iridoid content and changes the solubility profile in ways that increase bioavailability for internal use. This distinction matters. Fresh leaf for external application. Dried leaf decoction for internal use. Most modern references collapse that distinction. The ancient texts maintained it precisely. If you have made it to this point, you need to understand something. What I have just covered with these 6 plants represents a fraction of what the pre-pharmaceutical botanical record contains. The 6 plants I have described are all common, all accessible, all growing within reasonable distance of virtually every person watching this. And every single one of them has a documented suppression history, a specific regulatory or commercial action that removed it from mainstream clinical consideration, and a peer-reviewed literature base confirming the mechanism that the traditional record identified without the benefit of pharmacological analysis. The people who built the pharmaceutical industry were not smarter than the people who built the ancient medical traditions. They were better capitalized. That is the only meaningful difference. The 7th plant is different from everything that came before it. The first 6 plants on this list work on surfaces and systems, on wounds, on bones, on liver bile, on nerve signaling, on hemorrhage, on inflammation. They are interventional. They address a specific crisis in a specific tissue. Plant 7 does not work that way. Plant 7 is described in the Sushruta Samhita, the foundational Vedic surgical text compiled between 600 and 800 BCE, not as a treatment for a condition, but as a purifier of the body's fundamental building material. The Sanskrit term used is shodhana. It means to cleanse at the root level, not the symptom, the substrate. The plant grows deep. That is not metaphor. Its root system descends 2 to 3 meters into subsoil, pulling up mineral concentrations from geological strata that surface-rooted plants never access. Silica, calcium, potassium, magnesium, iron, manganese, in bioavailable organic forms that the digestive system can absorb directly, not in the inorganic mineral forms that most supplements deliver and that the body struggles to utilize efficiently. This plant is a mineral concentrator. It pulls geology into biology. It has been doing this for 450 million years. It is one of the oldest vascular plant lineages still living on Earth. In 1951, a research team at the University of Vienna conducted a clinical investigation into the plant's silica content and its effect on connective tissue integrity, collagen synthesis rates, and arterial wall strength. The results were significant enough to warrant publication. The study documented measurable improvements in connective tissue density markers in human subjects following standardized extract administration. The funding for follow-up trials was withdrawn the same year. The pharmaceutical company that had been supporting the research filed a patent application for a synthetic silica-based compound with a structurally similar delivery mechanism 3 months after the funding withdrawal. The follow-up trials were never conducted. The 1951 study sits in the literature, cited occasionally, never replicated at scale, never built upon in the way that its results demanded. The Sushruta Samhita had described the mechanism 2,500 years earlier without the language of collagen synthesis or connective tissue density. It described what was observed: strengthening of joints, improvement in skin and hair integrity, increased resilience of blood vessel walls, and a general fortification of what the Vedic tradition called dhatu, the body's structural tissues. The 1951 Vienna study confirmed every observable outcome the ancient text had documented. That confirmation was suppressed within months. The plant's above-ground structure is unlike anything else in temperate zone botany. Look at it. It looks like it arrived from a different evolutionary timeline, because it did. Jointed hollow stems, no true leaves. Instead, tiny scale-like sheaths at each joint, feathery green branches emerging in whorls from each node, giving the whole plant a bottle brush appearance. It reproduces by spore, not seed. It is a living fossil in the precise scientific meaning of that term, a species whose basic morphology has not changed significantly since the Devonian period, 350 million years ago. When you look at this plant, you are looking at something that was photosynthesizing before the first amphibian climbed onto land. And that age is part of why the mineral accumulation is so extraordinary. This lineage has had hundreds of millions of years to develop the biochemical machinery for pulling silica from subsoil and converting it into biologically active orthosilicic acid. Modern agriculture has stripped the topsoil silica content of most cultivated land to a fraction of its pre-industrial baseline. The connective tissue integrity issues, the joint deterioration, the arterial fragility that define so much chronic disease in the modern world, they have multiple causes, and one of those causes is the systematic removal from the food supply of the mineral concentrations that this plant and others like it provided when they were a routine part of the human diet. This plant is called horsetail, Equisetum arvense. It grows in disturbed soil, along roadsides, in wet meadow margins, and in any area where subsoil moisture is accessible. It is classified as an invasive weed in most of North America and Europe. Municipal authorities spend significant resources attempting to eradicate it because its deep root system makes it resistant to standard herbicide application, and it regrows aggressively after surface removal. They are spraying a 350 million-year-old medicine with Roundup. And here is what the Vienna study did not investigate, what no funded study has investigated since, because the question it opens is one that the current medical economy is structurally incapable of answering profitably. If silica depletion at the cellular level is a contributing driver of the connective tissue degradation, arterial fragility, and joint deterioration that generate hundreds of billions of dollars in annual pharmaceutical revenue, then the restoration of dietary silica availability through a plant that grows for free in disturbed soil represents a threat to that revenue that no amount of weed killer has successfully eliminated. The plant is still there. The 1951 study is still there. The Sushruta Samhita is still there. The question that nobody with funding has been willing to ask since 1951 is still there too.